Resistors in parallel. Resistors are said to be connected in parallel if they have a common positive terminal and a negative terminal, as shown here. Let us calculate the effective resistance of the circuit. Consider three resistors R1, R2 and R3 connected such that the resistors have common positive and negative terminals, as shown here. The resistors are connected to a cell through an ammeter. Observe the multimeter reading when it is used to measure potential difference across R1, R2 and R3. Now observe the multimeter reading when it is used as an ammeter. What do you observe? The current flowing through R1, R2 and R3 is different, and that the potential drop V1, V2 and V3 across R1, R2 and R3 is the same. Let us now calculate the effective resistance of the circuit. Let I1, I2 and I3 be the current flowing through the resistors R1, R2 and R3 respectively. Under ideal conditions, I is equal to I1 plus I2 plus I3. According to Ohm's law, R is equal to V by I. In a parallel circuit, the current flowing through the individual resistors varies. Hence, we first calculate I1, I2 and I3. Total current I is equal to V by R. I is equal to I1 plus I2 plus I3. Or V by R is equal to V by R1 plus V by R2 plus V by R3. V into 1 by R is equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This equation can be further simplified as shown here. Therefore, the effective resistance R is equal to R1, R2, R3 by R1, R2 plus R2, R3 plus R1, R3. Current divider. Two resistors connected parallel to each other act as a current divider. Let us consider two resistors R1 and R2 connected in parallel as shown here. The potential difference across each resistor is the same. V is equal to I1 R1, that is equal to I2 R2. The total current is equal to I, that is equal to I1 plus I2. The potential difference across the parallel combination of R1 and R2 is also V. The effective resistance of R1 and R2 connected in parallel is Rp. 1 by Rp is equal to 1 by R1 plus 1 by R2. Rp is equal to R1 R2 by R1 plus R2. V is equal to I1 R1, that is equal to I2 R2, that is equal to I Rp. I1 R1 is equal to I Rp, that is equal to R1 R2 by R1 plus R2 into I. I1 is equal to R2 by R1 plus R2 into I. Similarly, I2 is equal to R1 by R1 plus R2 into I. That is, current through one branch is equal to resistance of the other branch into total current divided by the total resistance. This is called current division law. The circuit is called a current divider. In domestic circuits, the bulbs are connected in parallel.